Hello everyone, welcome back in another video. I'm Avo and in today's video we are going to see memory allocation in Java. So before going to that point, we see what the main purpose is or which are the factors which depends on the memory allocation in Java. Basically, there is a JVM is a very much important point that which under the JVM all memory allocation will be done. So let's see before that what is JVM. JVM is nothing but the Java virtual machine. That is the toolkit comes with the Java that supports at the time of coding or it creates some environment for the code. We see what the function actually done by the JVM or what the process is done by the JVM. So JVM proceed like these things. First, the first function of JVM, it load the code. That means whenever any developer or any coder write any code, that code will be in a byte code. That code should be convert into the machine code, and that code load will be that code will be loaded in this package or in the specific manner. That is the first function of JVM. After that, the second function of JVM is that it observe the code for the errors and the unnecessary things in code or bugs in code. It analyze the throughout code, and it ensure that the code will be free from bugs and free from errors. After that, next point is that the next function of JVM is that JVM will run the code. That means the process flow or the path will be decided by the JVM. What actually execution is done within the code line by line or total at the one time code will be executed. That should be depend on the JVM, or how compilation will be done in the code. That also considered, or that should also depends on JVM. After that, there is one more function of JVM, that is JVM can convert the byte code into the machine code. That means it convert into the machine language. We are writing code in our language, that is the human language, and that JVM will transfer that code into the into the software understandable language, that is the machine language. It transfers the code from the byte code into the machine code. So let's go towards our main topic, that is memory allocation done in Java. So basically there is a 5 types of memory allocation done. First one is a class or method area memory. Second is a stack memory, then heap memory, then PC resistance, that is nothing but program counter resistance, and one more, that is the native method memory. We can see all of this one by one. So at initially we see first one, that is the method area. Method area memory means whenever we creating a code, that time we are writing different types of block of codes or different types of methods or different types of classes are there. So that's data will be or that code will be written into our class or our method or in our block, that will be stored in our method area memory. That means the block which will be written or the data will be written is stored into the method area. After that, the next memory allocation should be the most important memory allocation. That is the heap memory. Heap memory is important because of that whenever we are creating any new object, that time that object will allocate some space or some memory for the specific object or that new created object. By the help of when we creating new object, that time the memory should be allocated for that object in a heap memory. As we know, we are creating a object by using new keywords. In our previous example, as we seen, in this example we are creating a object by using new keyword like string s1 is equal to new string parenthesis like this case. That time we are creating a new object. In this case, that time that data or that constructor should have to allocate some space for that object. That space will be created in our that space will be created in our heap memory. The overall data will be overall data of our object will be stored in our heap memory. After that, our next point is that our stack memory. So in a stack memory, as we see, the stack memory will works on LIFO function. That is last in first out. That is the LIFO. That means when we create or inserting some data within our stack memory, that will be stored at the bottom. It's like a container structure. It store first element at the bottom, over then second, over then third, over then fourth. But when we are removing the element from the stack, it remove the first element, last element firstly. That for the same, we are using specific word for that. For inserting the data within the stack, we are called as a push method. By using push method, we are inserting the data within the stack, and by using pop method, we are removing the data, or we are capturing the data from our stack memory by using pop method. Let's suppose what actual function which will be done within the heap memory and stack memory we seen. As we discussed one of this example, that is a string s1 is equal to new string. That time the new string object is created in our heap memory. That means the overall data or the overall code will be stored in that object, and that object will be stored in our heap memory. But the reference which is created for the pointing the object, that is our s1. In this example, we are writing as a string s1 is equal to new string and parenthesis. There in this case, there is a s1 is the reference or the pointer for that object. That s1 will be stored in our stack memory. So object is stored in heap memory and the reference is stored in stack memory. That is the major difference, or that is the main purpose of using these two memories. That perform like these things. So in our as we see one more concept comes there, that is the garbage collector concept. When we create object in heap when we create object, it stores space in heap memory, but if that but the reference should be written in our stack memory if any object is present without any references, that should lead towards the garbage collector. That means any object will be stored within the heap memory without any specific references, that will convey towards the garbage collector or pointing towards the garbage collector. As you see in garbage collector concept, the garbage collector is nothing but garbage collector is collecting the data or object which is unusable or non-usable in our code. That data will be consuming some spaces or some memory. That the garbage collector can remove the specific code or eliminate that specific thing or code from our block of code, and make empty space for the another, and increasing the efficiency. That is the function of garbage collector. So if any object is present without the reference, garbage collector pointing towards that and it remove that object, and object will be stored. So after that heap memory and stack memory, we goes towards our next memory allocation. That is our next memory allocation is a PC resistance. PC resistance means nothing but program counter resistance. When we creating a thread in Java, that time that our PC resistance will convey with that method. That means it supports to that method, and the method which is created for the thread, it will be stored in our PC resistance memory, and it also functioning like a pointer for that thread in our Java. That is the function of PC resistance. And one more, our last memory allocation in a scenario, that is the native method memory. But actually, we are not using that native method memory in our Java. That is used in C. We are also called that native method memory as a C stack. So this is the shortly introduction about the different memories used in a Java. Thank you.